Hi, have a look at this equation. 1 plus 7 by 6 plus 7 by 6 whole squared plus 7 by 6 whole cubed, all the infinite terms. This is the sum of a divergent series and the sum is minus 6. Now in this video, I am going to justify this equation using Shiva's Casino approach. Now what is Shiva's Casino? Shiva's Casino is the philosopher's stone because at this casino both the Lucky 7 game host and the bet doubling player make money. Because of the paradox that both the host and the player are making money, this odd equation arises. So here we go. To justify this equation, we have to study a game played at this casino called the Lucky 7. What is this Lucky 7 game? In Lucky 7 game, the host presents the player 3 boxes, box A, box B and box C, and the player has to bet some money on one of these boxes. If the box chosen by the player wins, the player wins. If the box chosen by the player loses, the player loses. To decide which box wins and which box loses, the host rolls 2 dice and the sum of the value on top of these 2 dice is calculated. If that sum is less than 7, then box A wins and it multiplies your money 2 times and box B and C loses. If that sum is greater than 7, then box C wins and it multiplies your money 2 times and box B and A loses. If that sum is equal to 7, then box B wins and it multiplies your money 5 times and box A and C loses. Now using permutation combinations, we can see that the value on top of the sum of the values on top of these 2 dice can range from 2 to 12, where 2 is 1 plus 1 and 12 is 6 plus 6. And out of these are total 36 configurations, which is 6 into 6. Out of these configurations, 15 out of these configurations, the value is less than 7. 15 out of these 36 configurations, the value is greater than 7, and 6 out of these 36 configurations, the value is equal to 7. So the probability that the value is less than 7 and A wins is 5 by 12. And the probability that the sum is greater than 7 and C wins is again 5 by 12. And the probability that the sum is equal to 7 and B wins is 1 by 6. Now, if the player bets X units of money on box A, what is the expected money made by the host? Now, the expected money made by the host is equal to the money coming in the casino, X units of money, minus the money going out of the casino. That means twice of X multiplied by the probability 5 by 12. So this is equal to X by 6. This means that the expected money made by the host is bet amount divided by 6. Now we can prove and generalize this to the fact that the expected money made by the host will be equal to the total betting divided by 6. It does not matter whether the bets are independent of each other or not. This formula still holds. Read linearity of expectation for clarification. So the expected money made by host is equal to the expected total betting divided by 6, where the player bets more than one time. Now a bet doubling player comes along. What is a bet doubling player? A bet doubling player is one who starts by betting 1 unit of money and keep on doubling his bet subsequent bets until he wins 1 unit of money. Okay, so to study his game, I will make a table. This bet doubling player takes a loan of 1 unit of money and he bets that 1 unit of money. If he wins 2 units of money. From this 2 units of money, he will pay back the loan of 1 unit of money and keep for himself 1 unit of money. But if he loses, he gets nothing and a loan of rupees 1 unit will be standing on him. If he loses, he takes double the loan of the previous time and bets that, increasing the total loan to 3 units of money. If he wins 4 units of money. From this 4 units of money, he pays back 3 units of money loan and makes for himself 1 unit of money. But if he loses, he again takes a loan double the previous time, 4 units of money, and he bets that 4 units of money, increasing the total loan to 7 units of money. If he wins 8 units of money. From this 8 units of money, he pays back the loan of 7 units of money and makes for himself 1 unit of money. So I think you see the pattern. We'll do one more step. If he loses again, he takes double the loan of the previous time, that is 8 units of money, and bet that, increasing the total loan to 15 units of money. If he wins 16 units of money. From this 16 units of money, he pays back the loan of 15 units of money and makes unit 1 for himself. So this is the game of bet doubling player. At some point this player is going to win and he will win 1 unit of money. So expected winning of a bet doubling player is 1 unit of money. And what was the expected winning of the host? Expected total betting by 6. So this was the expected winning of the host. And if we add expected winning of the player, which is 1 unit of money, the sum should be equal to 0, because money cannot be generated out of thin air. If someone is winning, the someone has to lose by an equal amount of money. So the addition of both their winnings will be 0. This is the expected money made by the host, which is expected total betting by 6, and this is the expected money made by the player. To calculate expected total betting, we have to study the probability of each bet happening. So I will add one more column to this table. The first bet is certain to happen, so the probability is 1. The second bet will happen if the player has lost in the previous bet, so its probability will be probability of losing. The third bet will happen if the player has lost in previous 2 bets, so its probability will be probability squared of losing. The fourth bet will happen if the player has lost in previous 3 bets, so the probability of fourth bet happening will be probability of losing whole cube. So what is probability of losing? Probability of winning was 5 by 12. So probability of losing is 1 minus 5 by 12, that is 7 by 12. So this is equal to 7 by 12 whole squared, and this is equal to 7 by 12 whole cubed. So to calculate expected total betting, we will sum all these bets 1 plus 2 plus 4 plus 8 weighted with their probabilities. Now rearranging the terms here, expected total betting is equal to minus 6, and expected total betting is bet 1 is 1 unit of money into probability 1 plus bet 2 into probability of this bet happening 7 by 12 plus bet 3 into probability of this bet happening is 7 by 12 whole squared plus bet 4 into probability of this bet happening is 7 by 12 whole cubed, and so on, is equal to minus 6. So simplifying this equation, we get the odd equation with which we started, 1 plus 7 by 6 plus 7 by 6 whole squared plus 7 by 6 whole cubed plus all the way terms is equal to minus 6. So I have justified this equation, the divergent series summing to a finite number using Shiva's Casino approach. This equation, this odd equation arises because of the fact that at Shiva's Casino, both the host and the player are making money, which is a paradox. This is a new type of paradoxes which arises because of infinity. Interesting, huh? What do you think about it? Leave it in the comments. This video also exists to give you an intuition behind what it meant when Ramanujam said that the sum of all natural numbers is minus 1 by 12. That is also very disturbing to digest. That sum of all natural numbers should be infinity, right? The sum of this divergent series should be infinity, right? But it is equal to minus 6. We have just justified it in this video. Similarly, the sum of natural numbers according to Ramanujam was minus 1 by 12. So I hope you got an intuition that how can a divergent series whose sum is infinity be justifiably assigned a finite value. Thank you.